Hello dear students, I Jignesh Patil welcome you in this session of simple stress and strain. So as it mentioned simple stress and strain. So we are going to study about the basic definition related to stress and strain and also try to solve the basic numericals based on simple stress and strain. So let's start. So before any body experience any stress or strain, so it is in a condition of equilibrium. What it means, when the body does not undergo any kind of stress or strain, then that body is called as the equilibrium. As the definition says, when the system of force acting on the body is rest, then it's said to be equilibrium. So we have given an example in this, a block of body which is resting on table surface. So basically it having the weight which direct towards the downwards, whereas the normal reaction by the table is going upward. So both the reaction are same, that's why the book rests at the table, that means it is in equilibrium. So which kind of body we are going to study? So there are mainly three. So it is elastic body. A body regains its original dimension when the external load acting on it completely removed is called as body. What it means, you can keep in mind that's a elastic rubber. So as we stretch, it will deform, and as we remove the load, it gets its original size. So it will be elastic body. The second one is plastic body. As it right here, a body which get permanently deformed under the action of load and not coming back its original dimension on removal of load is called a plastic body. What it means, we can say the clay. It means we can give any size or any shape to the that body, so that will be plastic body. It means when we remove the force, it does not regain its original size and shape. And the last one is the rigid body, which means it does not undergo any kind of change. Means when we apply any kind of stress or force, so it will not change its shape or size, that is called as rigid body. Now in the type of load, we have to consider mainly three types of loads. The first one is direct load. The first one in the direct load is tensile. Tensile, which means you can consider as a pull. Pull means which is away from the center, you can say the outside load. Whereas compressive means the load acting inside, you can say the pressing, that's called as compressive load. The second one is eccentric load. Eccentric load is nothing but the load which acts some distance away from the center line, that is called eccentric load. So the eccentricity is defined by the E. And the last one is shear force. You can keep in mind the shear force as a cutting action, which means as you consider the scissoring action or cutting action, the two blades working opposite to each other, then the cutting take place. So the three are as it is the direct load, that is tensile and compressive, second is eccentric load, and the last one is shear force or shear load. Now the definition of stress. As I said, stress is nothing but the force per unit cross section area. You have to consider that force per unit cross section area, so that is called as stress, and it's denoted by sigma. The sigma is here. So stress is equals to force, that's P, upon unit cross section area, that is A. So P by A. As the SI unit, 1 Newton per mm square, that is megapascal. You have to keep in mind that megapascal means 1 Newton per mm square, whereas 1 kilonewton per mm square is 1 gigapascal, that is 1 kilonewton means 10 raised to 3 Newton. Now we have to study about the types of stresses. So which types of stress we have to study? First one is direct stress, as we get the idea of stresses. First one is tensile, that is positive, and compressive, that means negative. When we stretch any body, that means we are acting in a tensile load, a tensile stress. When we pressing any body, that means we reduce its size, that means compress it. That's why it giving a negative sign. Second is shear stress. That means we can say the two plates subject to shear force, that means cutting action. And the third one is bending stress. You can consider example of beam, that means it will get bent. Now the next is strain. Now strain is nothing but the change in dimension to the original dimension. What I say, change in dimension to the original dimension. It means what? If I take 100 mm rod and I stretch it to the 102 mm, so what will be strain? So strain will be 2, that is a change in size, divided by the original size, that is 100. So 2 by 100 is strain. So strain is classified according to application of load and mode of deformation. So as the linear strain, as I said, the change in length to the original length, that is delta L by capital L. Second, lateral strain. Lateral strain is what? If I stretch any rod which having circular cross section area, when I stretch it, the cross section area get decrease, that means diameter get decrease. So delta D upon D is strain. Whereas if I stretch a rectangular rod or beam, that time its width or and thickness gets changed, so that is delta B by capital B or delta T by small t, that is original dimension. The third one is volumetric strain, that is change in volume to the original volume. And the last one is shear strain, that means when we press or if we move the body from one position to another, or we just try to bend the position, that time the change in angle with the original angle will be shear strain. The most important law in stress and strain is Hooke's law. As it states, the stress is directly proportional to strain. The basic definition is, it states that when an elastic material is loaded within the elastic limit, then stress produced is directly proportional to strain. That means we have to keep in mind stress is directly proportional to strain. So as you made, stress is directly proportional to strain. So stress is equals to constant, and that is into E. Now capital E is nothing but your modulus of velocity or Young's modulus, which denoted by capital E. If small e is divided by sigma, so capital E is equals to sigma upon small e. Next is modulus of rigidity, that is shear stress to the shear strain. And the last one is bulk modulus, that is capital K, that is delta V by capital V, that is change in volume to the original volume. So we have to keep three constant numbers, that is a constant value, that is Young's modulus capital E, modulus of rigidity, that is capital G, and bulk modulus, that is capital K. So before solving the numerical based on sigma, E, capital E, delta, that means sigma means your stress, small e means strain, and capital is Young's modulus, and delta L means change in length. So we will start the first numerical. So we will read, a rod 1 meter long and 20 mm into 20 mm in cross section is subjected to pull of force 10 kilonewton value. Determine the stress. So we have to calculate the sigma, the given value P, that is load, pull, it is 100 kilonewton, which is 10 into 10 raised to 3, because it is kilonewton, so we will write 10 raised to 3 newton. Second, cross sectional area, that is 20 into 20, that will be 400 mm square. As our formula says, stress is equals to force per unit area, that is P is given 10 into 10 raised to 3 newton divided by area, that is 400, which is equals to 25 newton per m square. This is a basic numerical. We will move on second part, second numerical. A steel rod 500 mm long and 20 mm into 10 mm in section is subjected to axial load 300 kilonewton with the modulus of elasticity is 2 into 10 raised to 5 megapascal. Calculate stress, strain, and elongation of rod. Stress means sigma, strain means small e, and elongation of rod means delta L. So the given value is P, that is 300 kilonewton, that is 3 into 10 raised to 3 newton. Length of rod is 500 mm. Cross sectional area is 20 into 10, that is 200 mm square. and this is modulus of elasticity. Modulus of elasticity means E, that is 2 into 10 raised to 5 megapascal. So megapascal means nothing but the Newton per m square. So first we will calculate the stress as the formula P by the substitute the value. After calculation we get the answer 1500 Newton per m square. Second is small e, that is strain. So as the formula for strain is sigma E is equals to capital E into E. So just substitute the value, we make a modify the formula, substitute the value. By calculation we get small e is equals to 7.5 into 10 raised to minus 3. As strain is the ratio of two similar numbers or similar quantity, that's why it doesn't have any unit. So keep in mind the strain don't have any unit. The last one is elongation, that is delta L. So strain is nothing but the change in length to the original length, so delta L by capital L. So as we know, small is value we have 7.5 and capital L, that is 500. So substitute the value and by calculation we get the answer 3.75 mm. The last one, numerical, we have to learn about the shear stress and shear strain as we did. Keep in mind by the punching numerical. A force of 32 kN is required to punch a circular hole of 14 mm diameter in a metal plate of 2 mm thick. Calculate compressive stress developed in the punching rod and shear stress in metal plate. So this is a numerical based on punching. So we have to consider there are two stress. First one is compressive stress, means for the cross sectional area of circular portion, and the shear stress, which means what, the area around the circumference. So we'll look into some. So for we have the value P is equals to 32 kN, that is 32 × 10⁻³ Newton, and small t, that's diameter is given 14 mm, and the thickness of the plate, that is thickness of plate is 2 mm. Now we have to calculate compressive stress. The compressive stress means what, the area, this one, the area under the stress is this circular portion. So what is the area of circle? Yes, we know pi by 4 d square, that is A is equals to pi by 4 d square, that is pi d square upon 4, same. So substitute the value, we get answer 153.94 m square. This is your area for compressive stress. So the stress will be P by, so 32 × 10⁻³ divided by the area we have calculated. So final answer will be 207.87 Newton per m square. This is for the compressive, in this circular area. Now next is shear stress. Now the force is same, but the area which is affected will be different. Now this shear means what, as I earlier explained you, the two opposite forces. So as shear stress means what, the circular area of this portion, what it means, the circumference of the circle is in the influence of shear. So what the area or what the length of circular portion, that means the circumference of the circle. So as we know the formula, the circumference of circle is pi d. So we know the area affected is pi d, and multiply by this thickness, that is pi d into t, that is pi dt. Just substitute the value, pi into 14 into 2. So the affected area will be 87.96. I repeat, this is shear stress. That's why we are only considering the circular area, that is circumference of this circle, multiplied by P. So that is 87.96 mm. After that, same, the stress will be P by A. So that will be 32 into 10⁻³ divided by 87.96, and the final answer will be 363.8 Newton per mm square. So for the shear stress denoted by Q, and the final answer will be 363.8 Newton per mm square. So that's all about the simple stress and the strain and basic numerical we have studied. I hope you will understand the whole scenario or whole concept about the stress, strain and the basic numerical. After this further part we will cover in the next part. That's all. Thank you. Bye bye.